everyone, I hope you all are doing really well. Welcome once again to my channel, and in this video I am going to show you how you create different types of services. Well, if you have seen my previous video, I have discussed about the different ways you can actually expose your applications that you are hosting as containers in a Kubernetes cluster, which is definitely with the use of a service. So service, it's basically another Kubernetes object that acts as an abstraction, right, in order to expose your application. So there are different ways of exposing your application using different types of services. One is a cluster IP, and the other one definitely is a node port and load balancer, and there are external name as well. But in this demo, what I'm going to focus is on the top three, which is the cluster IP, node port, and load balancer. Let's just revisit how basically the service to pods mapping works. So it's basically with the help of a key value pair that acts as that's the label that you attach during the creation of your pod, and service basically helps you with the with the mapping, that mapping basically is achieved with the help of a key value selector at the service implementation that helps you with the mapping of service to a pod or a set of pods. So we talked about the cluster IP as well as node port and load balancer type. So what cluster IP is specifically, so it's the default service type where an internal IP address is assigned and that is shared across multiple different services that the workloads basically that you are running. So if you want to have a front end application that you are exposing, or a database application that you're trying to expose, and that's running as container as pods, then you can create an internal cluster, which is basically a cluster IP type of service, and easily that could be utilized by other applications within the cluster for accessing. So let's see how to create that. What I will be doing is, let's try to create a manifest file for this cluster IP type demonstrations. But first of all, let's try to create uh, a manifest folder for you. And within the manifest folder, I will create cluster IP-demo.yml. Okay. And within this, I have a YML ready with me, YML file, and I'll just come and paste it over here. So if you're wondering that what I have pasted, so on the first part, it basically contains a deployment type of a kind of object that I'm asking it to create. And within that, I'm asking it to create two replica of this pod. And what is this pod? So I have used a public image available in the ECR registry, and from there I'm just using this image. And what does this image do? It whenever you try to access the container, it returns its IP address. So notice carefully what is the most important part is, even if you don't specify it, this is what the type of the service. So this is the service implementation, the service object definition, and below there you can specify a type as cluster IP or something else as per your requirement. And here you would be able to see that under the metadata section of this deployment, it has the label of app, which is app-cip. And here in the selector of the service, I have used the selector tag in order to map that, okay, this service is basically mapping to this deployment. And the pod that is basically the container that I am running is this container. It can be any container based upon what you need. So without wasting time, let's try to save it. And once I have saved it, I'll just use kubectl apply -f followed by the cluster IP. You'll find that two events have followed. So one is a deployment got created and followed by a service is created. So let's try to see by using this command. So kubectl get -a, it will try to give you all types of resources Sorry. So you need to use all and -a. So this gives you information about everything that is running in your cluster, irrespective of the namespace. And if you want to if you don't specify the namespace, so it basically picks up the default one. So let me run it for you once again for better understanding. Yes, so this is what I have created for now. Like this is going to be my service, and these are the pods basically which this service is pointing to. And this is the deployment and replica set that basically gets created once you create a deployment type of object. Okay, now in case I want to access this, so this specific service is accessible only through this cluster. So in order to access it, let me try to spin up another pod, kubectl run. Say the name I'm giving is test, while the image I would be using is an Nginx Alpine, say for example a lightweight. And I have actually created this pod test, and it uses an Nginx Alpine image. Now I want to execute, I'll try to execute kubectl exec hyphen it and test followed by curl http colon. So I need to access this service. So this is going to be the service name, and it should return a response. And you see here, so what I'm doing basically, quite if you're aware of like how Docker exe Docker commands works as well, so it's quite similar to that. You are basically trying to access the container, and you want to run these command within that container. And once you run that, it so test within the test pod, from the test pod you're trying to access this service, and this service is routing the request to either one of the pods. So if I try to execute it once again, I will be getting another IP. So these two are the IP of IP addresses of these two pods. So if I run a kubectl command again, kubectl get pods -o wide, so it basically gives a lot of information over here, and you will find these are the IP addresses that are associated with these two pods. Okay, so going back to the presentation, so this is the important part. So you need to specify either the cluster IP type or keep it you don't need to mention the type, then by default it picks up the cluster IP. Talking about the port, so port is basically the request port of the service. The service would be receiving the request at this port, and target port is the port of the containers, which is actually where your application is running. So that is all about the cluster IP part. Let me move towards the second section of the demo, where I will be showing you how to create a node port type of object. So in a similar way, I will create a node port hyphen demo.yml file for you, and within this I have pasted this content. So what does this content contains? So it has the same it has the same yeah, I think I'll code over here. It has the same deployment type of object that I'm defining, only the name and levels are a bit different. The image I'm using is the same. And talking about the service, the striking feature is these 2 points. The type here is no more a cluster IP. I'm using node port, and node port I'm assigning a value over here of 5 digits starting with 3000, like from 30,000. So if I go back to the presentation part, what happens is, if you want to expose your application through the node, one of the node ports, you can use a service type of node port. The range is from 30,000 to 30,000, like 32767. That's the default port range that can be utilized for exposing your application. And the application is quite easily available if you try to access the node public IP. Public or private IP depends upon how you are accessing the node, and colon the node port. So a typical example that I'm going to show you has this kind of YML specification. In the manifest, I have declared the node port as this 31011. In case you don't specify it, so in one of the ports within this range, they are taken up randomly and assigned for your node port. So let's go and try to deploy this. So I will save the file and kubectl apply -f node port demo. Now, quite similarly, deployment and service has been created for it. Let's try to access this. kubectl get all. If I try to get all, you will find that, okay, other than the CIP specific labeled pods, we also have entries for we also have pods that are created over here for the node port type. And if you see it clearly over here carefully, that the type is also specified node port over here for app-np-service. And as we are creating deployment in the manifest file, the corresponding replica sets and pods are created. So replica sets would guarantee that that many number of pods, whatever you have specified, are available up and running all the time. And let's try to access this. So how do you access this this service of APPNP? Okay, so how do we do that? It's quite simple. The port we have used is 31011, right? Quickly, we'll get hold of the IP address of this node where the application is running. So say for example, it is node 1, right? Node 01. So I will try to simply perform a curl operation on this. So this is available from anywhere. If the node is publicly exposed, it is available simply with the help of node's public IP address followed by the port, which is 31011. If I specify this, you will find two variants of the IPs that are coming up, which is the IP address of this node port type of pods, node port type of objects, like service that I have exposed, that I have used in order to expose these pods. Talking about the third variant, so the third type of service is the load balancer type. So in that case, what happens is you would need to have some additional configurations. If you are using a cloud based solution or a cloud platform in order to provision a load balancer for you, in that case you would require a controller accordingly, right? So what typically people uses are, there are different ways of using it. So one of the famous way is definitely using AWS load balancer controller, in short LBC. So if load balancer controller, what it would happen is, in case of that service, you need to specify the type as load balancer. The port and target port can vary accordingly, but what happens if you, so those load balancer controllers are, you need to run them as separately in your cluster, and on your behalf it helps you with the creation of application load balancer in case you want to use ingress, which is another type of object I will be discussing in the future videos. And the other type is the service, if you are trying to expose a load balancer type of service. So it would, they run as controller pods, replica sets, and they continuously monitor the requests that are coming up, in case it is a request to create an ingress, or it is a request to create a service of load balancer type, and accordingly it provisions the elastic load balancer resources for you on your behalf. And if, as you can see on the screen, you will find under the external IP the DNS of the load balancer that gets automatically available, because the load balancer controller creates that on your behalf. So in the Killer Coda environment, we don't have much uh, control or visibility of how to create that, like the load balancer type of object. Like we can create a service of load balancer, but we won't be able to provision a load balancer in reality. But there is a way I can just show you how you create it with the help of a YML file. So say for example load balancer demo.yml. So if I paste it over here, I have pasted the content, and the deployment part remains the same, only for the renaming as per the convention I'm following. And under the service type, you see here the type is a load balancer. So let's try to save it, and load balancer demo. So you see same, the deployment and the service is created. And if I'm trying to get SVC, get all types of services, so you will find that I already had a cluster IP type service created, a node port type service created. But now when I'm specifying it as a load balancer, it's the external IP is shown as pending, because we don't have any kind of a controller that would help you with the provisioning of a cloud based load balancer or any kind of load balancing solution. So in this case, what's happening is you will be able to use an external load balancer. So when the clients or the external edges, they will try to access it, the load balancer would route the traffic directly to your pods, and the pod would be accessible in that case. However, there are, as I mentioned, you would require something called load balancer controller. So in my next video, I will be showing you how those things work, like how ingress can be created and what ingress is. And if possible, I will show you a demo on how load balancer controllers can be used to create a service type of load balancer and an ingress. So for now, that's it. And I hope you liked the video, and definitely keep on learning. And if you have any questions, if you have any concerns, feel free to put a comment on the under the comment section. And wish you a great day ahead. And once again, this video is not sponsored or not endorsed by any organization, and all opinions are mine. Thank you. Wish you a great day ahead, and cheers.